And once again, read this important message that you all want to hear. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to take a look at section 2.2. But before we do that, there were some questions emailed to me, so I'm going to start with those. Oh, I just want to remind you of the Math Center hours for those of you that are interested in that. So especially if you're trying to get help in the evening time, contact them and they should be very helpful. There's a Zoom ID meeting number there. Okay, anyway, this is from section 2.1, number 9. And as I mentioned yesterday, or I think I did, your problem number 9 might be different from the one I do. The numbers that are in red in WebAssign vary from person to person. So don't panic if you're going, that's not the number 9 I have. Okay, so the problem says we've got negative 9a over 5 equals 13/15. The directions say use a property of equality to solve the equation, then check the result. Okay, so we are going to multiply both sides of the equation by the reciprocal of the coefficient of the variable. All right, the variable is a. Its coefficient is -9/5, so its reciprocal would be -5/9. The reason we choose that is because a number times its reciprocal equals 1. So -5/9 times -9/5 is 1. 1 times a is a. So we've isolated a, the variable. On the right side, -5/15 reduces down to -1/3, dividing the top and the bottom both by 5. So I now have, don't panic, here we go, -13. When I say don't panic, I'm talking to myself here. -13/27. Okay, any questions about that? Let's check our work. So we'd have -9 times -13/27 all over 5. So I've put that in the place of a equals 13/15. Well, I can take this and reduce the -9 over 27 to -1 over 3. Okay, so now what have I got? I've got 13/3 all over 5. Okay, so this is 13/3 all over 5. But 13/3 divided by 5 is 13/3 divided by 5 is 13/3 times the reciprocal 1/5, which is 13/15, and that equals the 13/15 on the right side of the equation. It was harder to check the work than it was to do the problem. Sometimes that's true. But I'll tell you, if there's engineers building a bridge, I want them to spend a lot of time checking their work before I drive over it. Anyway, the answer is correct. Okay, that takes us to number 13 in that same section. And let's see here. Use a property of equality to solve the equation, then check the result. We've got 1/12 equals h plus 9/4. Okay, so I keep getting texts from students having problems getting into class. Sorry about that. I'm leaving my phone on because I'm expecting the furnace guy to come. It's gotten a little cold in here. Okay, sorry. Anyway, so we're going to use the subtraction property of equality here. We're going to subtract 9/4 from both sides of the equation in order to isolate the variable h. On the left side, I now have 1/12 minus 9/4. But to subtract those two fractions, I need a common denominator. Well, the least common denominator of 12 and 4 is 12. Do you have any questions about how I got that? If you do, I'll be happy to go through it. Nope. Okay. So we're going to get that. Well, 1/12 stays 1/12. 9/4 will multiply the denominator by 3 so that the new denominator is 12, which means we have to multiply the numerator by 3. The new numerator is 27. But now I've got 1/12 minus 27/12, which is negative 26/12. But I can reduce that because both negative 26 and 12 are even. So dividing the top by 2 and the bottom by 2, I get h equals negative 13/6. Okay, let's check our work. So now we have 1/12 equals negative 13/6 plus 9/4. Well, let's see. To add the two on the right, the least common denominator there would still be a 12. So I'm going to take negative 13/6 and multiply it by 2/2, which becomes negative 26/12. I'll take 9/4 and multiply it by 3/3, which becomes 27/12. So now I've got 1/12 equals, well, negative 26/12 plus 27/12 is 1/12. So it checks. Any questions on that one before we move on? Okay, I've got one more. This is also from section 2.1. This is number 18, part D. Solve the equation, then check the result. We have x over 4.5 equals negative 18.9. So I'm going to use the multiplication property of equality, and I'm going to multiply both sides by 4.5. On the left side, the 4.5 in the numerator and the denominator simplify down to 1/1, and 1 times x is x. On the right side, I've got negative 18.9 times 4.5. I'm thinking it's calculator time. So I'm going to go negative 18.9 times 4.5. And I get negative 85.05. Does anybody want me to go through the multiplication without the calculator as to how I get that? Anybody? Nope. Okay. All right, so that concludes the questions that people asked me. So now we're going to go on to section 2.2. And let's see here. That. And we should be good to go. All right. So yesterday, we dealt with equations where we had to add or subtract from both sides of the equation to move some terms over or back or whatever. And then we looked at the multiplication and division properties of equality where we dealt with a coefficient of the variable to get rid of that. Today, we're going to look at problems where we have to do both things. We have to move some terms and get rid of some coefficients, okay? The first thing I'm going to do is look at some problems where they give a proposed answer, and then we'll plug it in to see if it works, okay? So that's where we're going to start here. So let's see. This problem says, where is it here? You know what? I lied. They don't even do that. They just go straight. I must have looked. I'm having a Monday. Okay, we won't do that. We'll just jump right into some problems. So rather than just checking our work, negative 8x plus 1 equals 73. Okay, so you hear all about mantras, okay? Well, the mantra for this section is isolate the variable term, then isolate the variable. Isolate the variable term, then isolate the variable, okay? Now, the variable term is the term with the variable and it includes its coefficient, okay? So let's take a look at this. Negative 8x plus 1 equals 73. So the first thing I want to do is isolate the variable term. To do that, I've got to get rid of that plus 1. So what I'm going to do is I'm going to subtract 1 from both sides of the equation. That gives me that, because the plus 1 and the minus 1 cancel each other out. So now I've isolated the variable term. Now I'm going to come back and isolate the variable, which means now I'm going to get rid of its coefficient. So I'll divide both sides by negative 8. The negative 8 over negative 8 reduces to 1 over 1. 1 times x is x. And on the right side, 72 divided by negative 8, positive divided by negative would be negative. 72 divided by 8 would be 9. So the answer, x equals negative 9. So we isolated the variable term, then we isolated the variable. Okay with that? Any questions there? All right, we're going to check our work. Negative 8 times negative 9 plus 1 equals 73. So I put that answer in the place of the variable. Negative 8 times negative 9 is positive 72. 72 plus 1 is 73. 73 equals 73. The answer checks. So this is correct. All right. Any questions? Okay. Let's see here. Let's do this one. 2/5 C minus 12 equals 2. So isolate the variable term. So 2/5 C is the variable term. I've got to get rid of that minus 12. So I'm going to add 12 to both sides of the equation. The minus 12 and the plus 12 cancel each other out. So I've got 2/5 C equals 2 plus 12 is 14. So I've isolated the variable term. Now I'm going to isolate the variable. Well, because the coefficient of the variable is a fraction, I'm going to multiply both sides by the reciprocal of the coefficient of the variable. So this weekend, when you're at a party and you want to impress people, say, oh, so you just multiplied both sides by the reciprocal of the coefficient of the variable. And they'll look at you and like, whoa, are you a rocket scientist? Probably wouldn't work, but you never know. All right. 5/2 times 2/5 reduces down to 1. 1 times C is C. Over here on the right side, 14, this is like 14 over 1, right? 14 over 2 reduces to 7 over 1. 7 times 5 is 35. We isolated the variable term, and then we isolated the variable. You're going to get sick of hearing me say that, but that's okay. I want it stuck in your head. When you're trying to sleep tonight, I want you to be laying there going, isolate the variable term, isolate the variable. You'll be mad at me, but at least you'll know the process. Okay, here we go. 2/5 times C minus 12 equals 2. The 35, that's like 35 over 1. 35 over 5 reduces to 7 over 1. 2 times 7 is 14, and over 1 is still 14. 14 minus 12 is 2. 2 equals 2. It checks. All right. Let's see here. How are we doing? We've got -1 minus h equals -9. Okay. Let's see here. All right. So we're going to isolate the variable term, which means we're going to add 1 to both sides of the equation. All right. Now, what is the coefficient of H? Anybody? Volunteers from our studio audience?
Would it be 1?
-1. There you go. You were so close. It's -1. Okay, so what we're going to do now is divide both sides by -1 because we want to get rid of that negative sign as well. So negative over negative is positive, so we get H equals, and negative divided by negative is positive, so H equals 8. Okay, so plug it, there you go. Good. So -1 minus 8 is -9. -9 equals -9. So it checks. We good? All right. Let's see here. We've got 2 times -3a plus 2 plus a equals 2. Wow. Things got complicated in a hurry, didn't they? What we're going to do is we're going to simplify each side of the equation before we do anything else. So I'm going to look at the left side of the equal sign. Okay. Inside the parentheses, these are not like terms. One's a variable term, one's a constant term. I can't do anything there. So what I have to do is distribute the 2. So I'm going to get 2 times -3a, which is -6a, plus 2 times 2, which is 4, plus a equals 2. All right, we okay with that so far? Any questions there? All right, now I'm going to combine like terms. These two terms are alike. -6a plus 1a is -5a, and I still have plus 4 equals 2. So I've simplified the left side of the equation. Now, the right side of the equation is already simplified as much as it can be, okay? So now we're going to isolate the variable term and then isolate the variable. So my next move is going to be to subtract 4 from both sides of the equation so that I isolate the variable term. 2 minus 4 is -2. Okay. Then I'm going to isolate the variable by getting rid of the -5 coefficient. So I'm going to divide both sides by -5. -5 over -5 reduces down to 1. 1 times a is a. On the right side, negative divided by negative is positive. So I will rewrite that as just 2/5. Okay. Any questions there?
Yeah, how did you get -5a?
Where did I get this in the first place?
Yeah.
Okay, so up here, I combined all of the a's. I had -6a and plus 1a. So -6a plus 1a would be -5a. You okay with that?
Yeah, okay.
All
Thank
right.
you.
Good. Any other questions on that part? All right.
Yes.
Yeah.
When you actually, or I should say, why wouldn't you divide -2 divided by -5? Why leave it as a fraction?
Oh, that's a good question. Yeah. So you want to turn it into like a decimal?
Yes, that's what I would think if I were to do this equation.
Okay. That is not wrong, but it is not necessary. In other words, having a fraction answer is an acceptable form of an answer. You would want to reduce it. Like, let's say if it was let's say it was -4 over -10. I would reduce it down to positive 2/5. But I don't need to write it as 0.4. It's okay, it's correct if you do that, but it's not necessary. You'd want to reduce it, and then that's okay. Now, if it specifically asked for a decimal answer, then yes, you would need to do that, but otherwise you don't have to. Another case where you might just do it anyway, let's say you had a problem. In fact, we're going to look at some problems involving decimals. So then your answer maybe would be more appropriate as a decimal, but still not necessary. Okay. No, good question. Ask those questions. Anything else there? All right, let's check our work on this thing. Okay, so leave some room here. Okay, so I've got 2 times -3 times 2/5 plus 2 plus a, which is 2/5 equals 2. So every place that the variable appeared in the original equation, I'm going to replace a with 2/5. And again, if you will 0.4, you could replace it with 0.4 and still get there. Okay. In fact, as we're doing this, you might decide the decimal would have been easier. Okay. So I've got 2 times, this is going to be what? -6/5 plus 2 plus 2/5 equals 2. Okay. 2 times -6/5 plus 2 is equal to 2/1. And I'm going to multiply that by 5/5 to get so that I end up with 10/5. So 2 became 10/5, right? Yeah, and you're probably smiling going, yeah, decimal would have been so much easier. I totally agree. Totally agree. But that doesn't mean you can always avoid fractions. So 2 times, let's see, -6/5 plus 10/5 would be 4/5. 2 times 4/5 is 8/5. 8/5 plus 2/5 is 10/5, and 10/5 is 2, so 2 equals 2. And 3 hours later, we have we've checked our answer. Okay. Do you want me to go back and use 0.4 and check it? Nope, you're good. Okay. All right. So the score: students 1, teacher 0. All right. Let's see here. 10m minus 14 equals 11m plus 13. So now we have an equation that has more than one variable term. It's got a variable term on both sides of the equation, and it's got a constant term on both sides of the equation. So to isolate the variable term, I have to get all the variable terms together on one side of the equation. Okay. Now, it doesn't matter which side of the equation you solve for the variable on. You can solve it with the variable on the left. You can solve it with the variable on the right. Either way is correct. Some people will do it a certain way to avoid negative coefficients and all that, and that's great if you want to do that. I'm not going to bother. I just like to have it on the left, so I'm going to solve it on the left. So that means I need to get rid of the variable term on the right. So I'm going to subtract 11m from the right side so that the m's are no longer there. But that means I also have to subtract 11m from the left side. Whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. Okay. 10m minus 11m would be -1m. Okay. And then minus 14 equals 13. So I've got the variable term all on one side, but I still haven't isolated the variable term. So what's my next move going to be?
Add 14.
Correct. So we'll add 14 to both sides. -m, those cancel, equals 27. So now I've isolated the variable term. Isolate the variable. Well, our coefficient is that -1 again. Negative divided by negative is positive. M equals positive divided by negative is negative. So we get -27. All right with that? Okay, and we'll check our work. 10m minus 14 equals 11m plus 13. Okay, 10 times negative 27 is negative 270. Negative 270 minus 14 would be what? Negative 284. Okay. 11 times negative 27, let's see, that would be negative 270 and negative 27, negative 297, negative 297. Okay. And negative 297 plus 13 would be negative 284. It checks, and we're correct. Score, students 1, teacher 1. I'm catching up. Okay. Now, here's where the real fun begins. 2/3 x plus 2/3 equals 3/4. Now, we could subtract 2/3 from both sides of the equation, take 3/4 minus 2/3, get a common denominator, put them together as a single fraction. Then we could come back and say, oh, we've got to get rid of the 2/3 of the coefficient of x, multiply both sides by 3/2, blah, blah, blah. We could do all that. Nothing wrong with that, but we're going to look at a better way. Okay. The first thing we're going to do with this problem is we're going to get rid of all the fractions. Yay, fractions. Okay. To do that, we need to find the least common denominator of all the fractions. So I've got a 3, and a 4. Those are my denominators. So the least common denominator would be 12. Is everybody okay with where I got the 12? All right. Now, I'm going to multiply both sides of the equation, everything on both sides of the equation, by the least common denominator. Okay. And I'm even going to put it over 1 just to remind you that that 12 is in the numerator. All right. Let's make that a little neater. Penmanship is not my forte. Okay. Now we're going to distribute the 12 on the left side and multiply the 12 on the right side. Okay. So I'm going to get 12 over 1 times 2/3 x. Okay. Plus 12 over 1 times 2/3 equals 3/4 times 12 over 1. So I've multiplied each term, on both sides of the equation by the least common denominator of the entire equation. What's going to happen is I go through and simplify each product. The denominators are all going to turn into 1s. Okay. 12 over 1 times 2/3 x. 12 over 3 reduces to 4 over 1. I now have 4 times 2, which is 8x all over 1, so just 8x. The fraction's gone. Plus 12 over 3 is 4 over 1. 4 times 2 is 8. 8 over 1 is still 8. And again, the fraction's gone. And then 3/4 times 12 over 1. 12 over 4 is 3 over 1, and I get 9. Voila, the fractions are gone. Okay. Now we proceed as before. Isolate the variable term. I'll subtract 8 from both sides. Isolate the variable. I'll divide both sides by 8, and x equals 1/8. See how that worked? Now, you may be sitting there going, I don't know if I want to do that. I feel more comfortable subtracting 2/3 and getting common denominator and building them and blah, blah, blah. Once you master this, you'll think it's the best thing since sliced bread. Okay. You'll want to do it this way. So force yourself to practice this method rather than the old way. Once you get good at it, you'll be like, oh yeah, this is great. Okay. All right. We have to check our work, and hopefully I've left enough room to do that. So I've got 2/3 times x, which is 1/8, plus 2/3 equals 3/4. 2/8 is 1/4. So I've got 1/12 plus 2/3 equals 3/4. Well, let's build everything up to 12ths. So I've got 1/12 plus so many 12ths equals so many 12ths. 2/3 I'm going to multiply by 4/4 and get 8/12. 3/4 I'm going to multiply by 3/3 and get 9/12. 1/12 plus 8/12 is 9/12, and 9/12 equals 9/12. Woohoo! Correct. Okay. A lot of work, huh? Yeah, boy. You're glad I did it. You just got to sit there and watch and eat popcorn and be entertained while the teacher does all the work. Don't worry, your turn's coming. Okay. Let's see here. How are we doing for time? I'm going to do that. Okay. Let's see. We've got this problem. 0.02 times 62 minus 0.08x equals 0.06 times x plus 9. Okay. Now, I have decimals, and we could live with the decimals and use our calculator and take 0.02 times 62 and all of that. Nothing wrong with that, but I want to get rid of the decimals. Recall that to move a decimal point one place to the right, you have to multiply by 10. To move it 2 places to the right, you'd multiply by 100, 3 places, 1,000, etc. Also, whatever I do to one side of the equation, I have to do to the other side of the equation. As I look at my decimals, I see that to get rid of them, they all would need to move over 2 places to the right. So what I'm going to do is I'm going to multiply both sides of this equation by 100. Okay? Now, distributing the 100, I'm going to have 100 times 0.02 times 62 minus 100 times 0.08 times x. And over here, I'm going to have 100 times 0.06 times x plus 9. Okay, so I've distributed the 100 as a multiplier, just like in the previous problem, we multiplied everybody by the least common denominator. Now we're multiplying everybody by a product, what am I saying, a power of 10, so 10 squared or 100, okay? Now, you multiply from left to right. What's 100 times 0.02? That would be just 2. And 2 times 62 is 124. Okay. What's 100 times 0.08? That would be 8, and then times x. Okay, there. Over here, 100 times 0.06 would be 6, but once I've taken the 100 times the 0.06 and gotten 6, now going on, I take the 6 and distribute it to get that. Okay, notice up here, I did not distribute the 100. I took the 100 times 0.06, got the 6, and then distributed the 6. You okay with that? All right. So now I've got an equation. Let's put all the x's on. Let's put them on the right this time. Okay. So to put x's on the right, I'm going to add 8x to both sides to get rid of it on the left. I get 14x plus 54. Okay. But I want to isolate that variable term. So I'm going to subtract 54 from both sides. And I'm going to get, let's see, 14x equals, oh, what is that, 70? Yeah, 124 minus 54 is 70. I know because I stayed up all night practicing that one problem just so I'd get it right, hopefully. And now we're going to divide both sides by 14, which gives us x equals 5. Okay, so x equals 5. You all right with that? So the last two problems, big stuff. We had an equation with fractions, multiplied both sides by the least common denominator to clear the fractions. We had an equation with a bunch of decimals, multiplied both sides by a power of 10, in this case 100 or 10 squared, to get rid of the decimals. Okay. Now, we're going to look at two other scenarios, and I'm just going to go ahead and do the problem, and then we'll talk about it. Let's see, we've got 8x plus 3 times the quantity, 2 minus x, equals 5x plus 6. Okay. I'm going to simplify both sides of the equation. So on the left, I'm going to start inside the parentheses. 2 minus x. Those are not like terms. I can't force them together. So I'm forced to distribute the 3. 3 times 2 is 6. 3 times minus x is minus 3x. On the right side, these are not like terms, so I can't do anything there. Back to the left side, I can combine these two like terms. 8x minus 3x is 5x. Okay. So far, so good. Notice something. The left side of the equation looks exactly like the right side, doesn't it? Well, let me see if I can convince you of something. Okay. First, I could. Well, let's just carry on the way we normally would. I'm going to put all the x's on the left side of the equation. So I'm going to subtract 5x from both sides. Oh, I'm going to get 6 equals 6. Well, that's true, but x disappeared, so I don't know what x is. Well, let's go back and try a slightly different approach, okay? Just to try and convince you of something. What if I subtract 6 from both sides? I'd get that, wouldn't I? Right? What if I divided both sides by 5? I'd get that, right? X equals x. Well, if x equals x, what could x be that would make this a true statement? Could x be 714?
No, it'd be 1.
It could be 1, but couldn't it be 714? Doesn't 714 equal 714?
Yes, it does.
So x could be 714. Could x be negative 3.218?
X could be anything at this point.
Bingo! It could be any real number. So x equals all real numbers. This is what's known as an identity, where both sides are exactly the same, they're identical. So the solution is all real numbers, because if you can get it down to the variable equals the variable, you could put any real number in the left and the same thing in the right. Okay. Now, I want to go back to something that you said, and you may have thought this, you may not, but I want to deal with it when you said x equals 1. That is true, it would work, but keep in mind x itself, just out of the blue, x does not equal 1, x equals 1x. Okay. Because I've had people say, well, isn't x equal to 1? No, x is equal to 1x. If we knew x was 1, we could all go home and say, well, we don't have variables anymore. Are you seeing that? Kind of wrap your head around that. Okay. All right. Now, another scenario. 5 times x plus 2 equals 5x minus 2. Okay. So we've got, let's see, we've got to simplify on the left side of the equation. So we get 5x plus 10 equals 5x minus 2. Well, the last equation, the left and the right, were identical looking. Here, I don't know if you can see it, but we've got a problem. Well, of course there are problems, but let's get rid of the variable on the right. We'll subtract 5x from both sides. Oh, does 10 equal negative 2? So there is no solution because we get a false statement. So there's no variable that we can, no number we can plug in for x that is going to make this statement true, because I end up with a contradiction there. Okay, so here, this previous one, x could be all real numbers. Here, there's no solution. Are you seeing the difference there? Kind of tricky, huh? I know, yeah. Let's see. I want to do one more problem involving decimals, because I want to talk about something that might be a little bit tricky. Okay. So let's say we've got this 0.06 times a quantity a plus 200 plus 0.1a equals 172. I'm going to tell you a story about my family at Christmas. Okay. Years ago, I have a stupid story for everything, if you haven't figured that out yet. Years ago, well, I have 3 siblings, 2 brothers and a sister. Okay. And my mother approached me one day before Christmas and she said, I've decided that I want to buy something significant for each child of hers. And so she asked me what I would like. And I can't even remember what it was, but I picked something out that I think was about $200. Okay, great. So then she said, okay, so that means I'm going to spend $200 on each one of my kids. So then she went out and bought $200 worth of stuff for each kid. Well, the point of the story was that she treated each kid the same. She didn't look at their monetary worth, whether they were good looking, like me, don't say anything, she just said, I'm going to give everybody a $200 present. Okay. Now, what does that have to do with this problem? Here, to get rid of the decimal, we'd have to multiply by 100. You see that? To move it over 2 places. Here, to get rid of the decimal, we'd only have to multiply it by 10. Here, there's no decimals to deal with, so we could just leave it alone. But we can't come in and say, oh, we're going to multiply this one by 100, this one by 10, and this one not at all. That wouldn't be fair. So everybody gets what? Everybody gets 100. Okay. And actually, the story about my family, it was true. Some of my stories are true. Others, you kind of have to figure out at what point does he start lying. Okay. So we're going to multiply both sides by 100. Okay. So here I get 100 times 0.06 times a plus 200. Here I get 100 times 0.1a, and over here 172 times 100. Okay. 100 times 0.06 is 6. 100 times 0.1a would be 10a, right? So I'm not just getting rid of the decimal, I got to move it over 2 places. And then on the right, 17200. Okay. So the decimals are gone. Now I'm going to distribute 6a plus 1200 plus 10A equals 17,200. We're going to combine like terms. 16A plus 1200 equals 17,200. Isolate the variable term. Subtract 1200 from both sides. 16A equals 16,000. Divide both sides by 16. A equals 1,000. Okay, we all right with that? And I should check my work, but I'm feeling lazy and time's almost up, so I'm gonna do as I say, not as I do. Anyway, I will be back this afternoon at 1:15 if you should have need of me during that Zoom office hour. Otherwise, I will see you all tomorrow. Thanks for showing up. I'm going to stop the recording.